So, GraphQL, what does that have to do with React? Stu mentioned at the beginning that Facebook is just about to release Relay, which is the application framework for React, and that's internally using GraphQL. But this is not about Relay or how GraphQL relates to React or generally all that thing. It's just about GraphQL, and it's a really useful technology on its own. So I just want to show you a sort of a practical demo, how you would use GraphQL, and how we use GraphQL at Financial Times on a project that I'm on. So who never heard of GraphQL? Oh, a few people. All right, so GraphQL was built to fix a problem. It's a practical thing. And the problem was with REST. So what's wrong with REST as an API backend? It's ID-based. You get an ID, and you get back some data. That sounds all right at the beginning, but then you need to get more data from more endpoints. And worse still, you need to get data by ID that comes from previous data. So you have like waves of requests that you need to perform. And you'd probably do more than just 3. So if you're doing all that over a slow network, that's a bit of a problem, right? Because like on a 3G network, firing off 50 GET requests will get really, really slow. So that was, I think, the original problem that GraphQL was designed to solve. And what it does is it's query-based. So you don't make multiple requests. You make a single one that fulfills exactly the client's data needs. So you get what you want, what you need, and only what you need. So you transfer the least amount of data possible, and you do it in one single go. It's a query language specification, so it's not a library for a particular language. It's just basically a definition of a language that people should implement in different programming languages. And therefore, it's programming language agnostic. So you can use it in whatever you want as long as there is an implementation available. And here's an example of what a GraphQL query might look like. So here, we're fetching an article by ID. And we want, for that article, we want an ID, a title, and some main image. And for that image of a particular width, because this is a small client, so we just want a tiny image, we get a source and an alt text. So that's GraphQL in a nutshell, and we'll see some demos and get into detail. My name's Viktor. I work for Red Badger. You can follow me on Twitter. You can find me on GitHub. So please do fire off any questions if you want. But let's have a look at what we can do with GraphQL. So let's go back to the problem with REST. We said speed might be an issue, but what if you don't have that particular problem? So this is, I think, a sort of a typical situation when you have a service-based backend with a bunch of REST services that you fetch data from. So you have a set of services at the top and then a set of clients at the bottom, and each of the clients use some of the services. And it's just from looking at it, it's a bit of a mess, right? And it gets worse still. It's not just hard to understand and use. What if I want to change that particular service? Because the data format that the service is returning is fixed, I now need to change both of those clients. So this doesn't really scale. Imagine if you have more clients and way more services, which is typically the case in larger organizations. So you might be thinking, well, I just have a website. I don't have a problem with multiple clients. It's fine. Well, that's not really different. You have a website with multiple pages. They fetch from multiple services in the backend. Situation's still the same. And it's not how many clients you have. It's the backend complexity. If you have multiple services that return multiple formats, then it's kind of a bit of a mess, which it always is because it evolved over time. You still have this problem. And GraphQL is sort of a middle layer that is meant to fix that problem. So instead of all of those pages talking to all of those services, the pages talk to GraphQL, ask it what they want specifically for that page, and GraphQL figures out how to fulfill that request using the set of backend services. So how does it work? So it's based on a user-defined type system. So for each use case of GraphQL, you defined a type system, which you can call a schema. And that basically says what data is available for use. And that's described by the GraphQL server. You define that, and then that's available for all the clients. And then the clients describe what data they require by asking queries. And the data fetching, so how do I get this particular thing in the schema, is user-defined as well, which means it's backend agnostic, and that's quite important. You can fetch data from a database, from a REST API, from like a satellite link or a pigeon-driven protocol or something, anything, as long as you can do it. And there is a reference implementation built by Facebook called GraphQL.js because it's written in JavaScript. And that's what we used, and that's what I'm going to show later on. It's on GitHub. It's currently a version 0.2, so it's quite early in its life. But it works really well. And what it lets you do is define a schema, and it can parse a query and execute it. And there is no network transport because the assumption is that you can do that with Node or something. It is just a query parser, executor, and a schema definition library. So I mentioned Financial Times, and we said that we use that at Financial Times. So what are we doing at Financial Times? You probably heard of Financial Times. It's a newspaper. They have a fairly big portfolio of online products as well. And the project we are on is called NextFT, and it's a project to replace and improve the current ft.com. It's been going on for about 12 months now, and it boils down, like I'm simplifying grossly, but it basically displays content from a set of REST APIs, driven by some CMS backends, which the editorial staff use to put content in. The interesting thing about Financial Times is that they do their development out in the open. So you can look at the project we've built, the next front page, on GitHub. It's public. And we can look at what it does. Wow, that's a small screen. Ooh, it's a very small screen. So here is the front page as it looks like on tablet. Let me try and zoom out to get a bit more. So there is like a set of sections on the page. There are the top stories at the top. There is FastFT, which is like a really quick news feed, updated quite often. Then there is an editor's pick section with some stories. There is an opinion section with less news-based and more opinion-based pieces. There are popular stories based on what people are reading. And then there are some topical sections at the bottom. So it's a bunch of different things. I was afraid this might happen because the top story can have related stories. Hopefully the international version has some. Yep. So there's a top story and has related content on it. So that's the page in a nutshell. And it's a single page, so it's not a huge product. But going back, it's driven, as I said, by an API backend. And that backend is fairly complicated. There is, CAPI stands for Content API. So there is Content API v1, Content API v2, which is the thing they're building now, which is meant to like simplify and unify the content fetching, but it's not done yet. Yet you still have to build a product on it. And there's different content available in those backends. So for instance, that FastFT feed is not in v1, v2 yet. And the response format from those two APIs is slightly different as well. And then there is like edit complexity, like CAPI v1. You can fetch through an Elasticsearch proxy, which does some interesting work around metadata for that content. But it doesn't have a 24/7 support, so it's a feature toggle that you can turn on and off if something goes wrong. And looking at the sections of the front page, it gets even worse. So top stories and opinions are coming from editorial-driven CMS pages, which is a type of API. Editor's picks is a mix of searches and pages moving towards lists, which is a v2 thing. FastFT is content by concept, which is like a search type thing, plus a notification feed for updates so that we don't poll the backend all the time. popular stories and live blogs, which are coming soon, are not coming from the C API at all. And then there is the added benefit of having related stories on the top story, which is an extra round of requests that you have to do if you want to show that thing. So that's just painful, right? There is so much stuff going on. You have to fetch from 50 different places. And it's not a Financial Times specific thing. It's just that API backends are complex. And part of the reason for that is that backend APIs are sort of storage-centric. So it's based around where the data is coming from and how it got there and what data is available in that particular thing. Whereas what you want for the front end is sort of a product-centric view. So for us, we just want those sections of the page named and be able to fetch content from that. And that's what GraphQL's sort of promise is and how we use it on Financial Times. So let's have a look at how that works. Right. So let's start by something simple. Let's start by fetching the top stories and just get a title for each. So we can start even without this. So GraphQL query starts with saying query, and you have to name it. And then there is a sort of set of entry points. It's quite small, isn't it? Can you read it? Is that better? Yep. So let's go for top stories. We have to tell it the region because as we saw that there is like a UK version and an international version. And we want a title for that. So let's send this. And we get back, yep, that's the front page. Well, that's not very useful. Let's fetch the items. Oh. And then for each of those, I want the title. Oh, good. So that should be what we saw on here. Wow. Yep, that's the thing. And I want to add, I can add arguments to some of those things, so I can say I just want 5 of those stories. I just get 5. And that's all user-defined. We define that schema. So even those arguments and everything like that, nothing's built in. You have to build it up. So let's say I want to get the related stories for that, for those 5 items. And for each of them, I want a title again. Yeah, that's working. So that was kind of easy. But what if I want related content for those as well? Yeah, it's nesting. And I could go on forever. And that's because it's based on that type system. So once you explain how you get related content on an item, and that it's a set of items itself, you just, out of the box, get this sort of infinite nesting. So that's quite a nice benefit. Because what we were doing before was reaching into that like one story and pulling out just some metadata around those related stories, but now we can very easily just fetch the real deal, the actual story from the backend, and then go again and again. But let's do one more thing. Instead of related content, I want to get a primary image for that story. And GraphQL is complaining. It says field primary image of type image must have a subselection. So I need to supply something in here, but I don't really know what. And here is a really nice feature of GraphQL. It has introspective capabilities, so I can say, tell me for this type named image, what fields are available. For each of them, I just want a name. And it says I have a source and an alt text. I can also get a description, which is a nice thing. That tells me what it is, which is what I wrote in there. So let's get a primary image and its source. And it says, nope, field source has an argument width of type int, and it's required, but I didn't provide it. So I can say width is 320. And that worked, and it gave me a URL, and it has a 320 at the end. And that's coming through a service called GB, which is like a CDN, which can resize images. So this is quite useful to just write in the query, say what size of an image I want, and I don't have to build this massive URL in the view templates. I can just get it right from the API. So if I go 750, it does what you would expect, 750. All right. So that was sort of a demo of introspection and how you can do clever things. So let's look at what the schema looks like. Oh God, it's tiny. Is that readable at least a little bit? So each of GraphQL schemas starts with a query type, which is sort of the top level entry point that you define. Right. Yeah, that should do. And so in the GraphQL specification, I should say, you see things like this. Define a type called person with a name, which is a string, and an age that is an int and picture. That's called shorthand, this thing, in the GraphQL sort of slang. And that thing doesn't really exist. It's just a sort of short way of describing types. There is some work in GraphQL.js to build a parser of that and a printer, and eventually I think it will get to a point where you could actually define your schema in this language. But right now you have to do it in JavaScript. And it starts like this. You create a new GraphQL object type, you give it a name and a description, which is useful for like documentation, and then define the fields. And one of those fields is top, which we saw before. And it's of type collection. And it has some arguments, which is the region. And it's a non-null argument, so it will require it. When we don't provide it, it will blow up. And finally, you have a resolve function, which is the sort of a core of how the fetching works. And the resolve function gets something provided by a parent of this, which in this case is just a root object, and the arguments. And we just look up some configuration and fetch a page from the backend, because top is a page. So what happens next? We return whatever this returns, which is actually a promise, because we're fetching from a network. And GraphQL will wait for that promise to fulfill, and then whatever this returns in the promise, it will pass down to collection. So we have to move on to collection and see what happens there. And collection is an interface type. So that's a bit of a complexity because we have multiple different collections. I said we have like pages and searches and content by concept and other things. So collection is an interface which just defines a common set of fields available on a collection of content. And the way it decides what type of collection it is it calls a resolve type function, which you define, figures out that it's either a page or content by concept. In this case, it's a page. So we move on down, and we can get a title for that page. This doesn't have a resolver because that is actually the name of the field on what that backend returned. So you don't have to do that because it's like an identity function. It would just be this.title or whatever comes in .title. And then it has the items. And they have a few arguments. Again, you can like limit and skip some items. You can even filter by things. But at the bottom, again, you call that backend, which we built, and fetch content v1 by items from whatever you got in. This is what that returned. So return value of that comes in as an argument here. And this is how the nesting sort of works. So whatever a field returns goes down to its type definition, and you can go on and resolve there. So content v1, again, returns a promise. And we say the type of this field is a list of content. So for each of those items, we would find a content type. And surprise, surprise, it's again an interface. And it decides whether it's a content v1 or content v2. So here is hiding the complexity of the backend. We don't really care that there are two different backends. We want content in the same shape for the UI. And it has a bunch of fields on it. One of them is title. It can decide which type of content it is. So like on v1, going down, There's a title field, and that's how you get it from the content. It's content.item.title.title, because it would be too simple if it was just title. And it can also do primary image, which is a bit more complex to fetch because there are multiple images on the REST response. You have to decide which one to fetch by priority, etc., etc. Goes to image type, and here we go. That's how you get source, and this is where we build the URL that we just saw with a width at the end. So this is kind of how you define the schema. And we can go back to the slide. Wow. So defining a schema is not the only thing that you need to do with when building things with GraphQL. There are like other practical issues. In our case, because there are multiple backends and it takes time to get things from them, as caching, which is kind of tricky. There is that Elasticsearch thing that I mentioned at the beginning, where you have to decide what backend to use. You might want to mock data, because like, having just a production API is a bit useless when you want to test with content that isn't published at the moment, like live blogs. And what we did for this is build a set of swappable backends, so you can supply that backend at runtime and decide which one to use. And the first attempt at that was to pass backend as a sort of a type parameter. So a type, like page, wouldn't be just new GraphQL object type. It would be a sort of a factory that you give the backend and it will return a type. And that just didn't work. That was like a horrible monstrosity. You don't do it. There is a much easier way. The second attempt was using the execution content of the GraphQL query. And that works like this. Come on. This is the entry point to GraphQL. You call a GraphQL function, give it a schema and the query that you got from the client. And then there is a third argument, which is the execution context. And we just pass in a backend, which decides whether to use Elasticsearch or not. And then also a FastFTP backend, but never mind that. So this works much better. And what happens at the bottom, we get like a collection. You get a third argument in the resolve functions, and that's exactly the same object. So we pull out the backend from that and use it. And this you could use for like authorization per field, or something similar that you want to decide in the actual resolver functions. So that works way better than what we've done previously. It's more flexible, keeps the schema clean, lets us do like mock data fetching and other things. I'm sure that the possibilities are endless in that case. So what's the result of this whole exercise? Well, at least in my view, it's significantly simpler and cleaner to fetch content like this than doing it manually. It gives you a lot of things for free once you define that schema. The implementation was very easy. It took about 3-4 days. It wasn't like too much time, and it's just JavaScript. It starts a little tedious. When you have nothing, you have to build up that schema. But it fairly rapidly speeds up because normally you don't have 50,000 types in your backend. You have like, even Facebook, you would have like users and groups and albums and pictures. And it's probably like, I don't know, 50 types, something like that. So once you define all of those, the big problem are the relationships and how they're fetched and filtered and all of those things. But then you say, right, this thing returns a user, and everything beyond that is already done because you've defined a user before. And a thing to keep in mind is that GraphQL.js, the reference implementation, is still very early. So there are like a few bugs, things are not quite finished, but the author of that, Lee Byron from Facebook, is very responsive, and they develop it quite quickly. The 0.2 version is like 3 days old, and that adds tons of features. So I'm guessing it will get stable fairly quickly. They work on it all the time. And that's it. Any questions? There's a question. Are they running mics? Oh yeah, cool.
Hi, how do you handle errors in GraphQL? Because with a REST API, you can sort of use HTTP status codes and things like that. But if you're doing a request that's equivalent to several REST requests at the same time, how do you kind of bubble the errors through?
So you can use .catch on promises and handle that, but it is one of the problems that the implementation currently has, is that it swallows errors. So it's quite tricky to get these out and figure out what's going on, and there is a plan to fix that. So hopefully it will eventually surface them at the top level. So it's a bit manual and a bit tricky at the moment. But yeah, that is a pain that we felt as well. So I must say I don't really know. There is a system for that in GraphQL, but we didn't need it because this is read-only. There is like a set of, you can define mutations, and then those get arguments, and I assume it's quite similar to the fetching. So you just get whatever the query contains in the mutation, and then you do it. But I don't know. I don't have practical experience with that.
This question is more for Facebook, because I remember during their talk about GraphQL, they say that they were having a lot of versions of the API, and it was helping them to store basically the schema on the client side, like that even if people don't update their apps, it still works. How you handle that well?
So as I understand, they keep all the fields that they've ever had until they completely go away in there, and you can mark fields as deprecated, in which case they don't show up in the introspection, but they still work if you fetch them. So you sort of migrate that step by step, field by field, and old clients still work. But new clients, when they ask for the introspection, they don't see those things, which is quite nice. That solves a massive issue at REST as well. All right. There's another one.
Are there any types of data that you think GraphQL would not be suitable for?
It's a good question. I don't know. Maybe binary data, but even that you can probably serialize somehow, or just link to a URL instead. I don't know. Don't think so. Like anything REST can handle, GraphQL can handle, and it seems like REST can handle most things. I wouldn't think so. I think it's pretty universal.
Hey, this might be an obvious question, but do you find there's temptation to, because there's a lot of complexity in the back end there, that you've got to make a lot of calls. Obviously, those calls are still happening. And what this can do is kind of just mask a whole bunch of stuff that's happening. And especially if you're using platform as a service, you're paying for database hits, for example.
Yes.
The cost is still there in time, even if it's the back end.
It's definitely there, and you'll feel that slowdown when you start doing like many nested requests or like complex queries. That will happen. So you have to be careful not going too crazy.
Is there a way to limit the nesting? Because basically from your example, I can just do that again and again and crash the server. If there is too many join within your...
So each of those resolvers gets the AST of the entire query, I think. So you could probably read that and like count the depth that you're in. I don't know, I've never tried that, but it's probably possible on the sort of parse level, but it's going to be tricky, I assume.
Any more questions?
I've
got a question for you.
Go.
So the introspection is brilliant, right? There's going to be loads of tools, I guess. Have you seen any?
I haven't seen them, but I've heard about a tool called Graphical that is about to get released as well, I think. I briefly chatted to someone from Facebook, and they said, we can't wait to get Graphical in your hands. Didn't say when, obviously, but hopefully soon. And that should be quite cool because it will let you use the introspection and build a query, a GraphQL query, with a UI. So I assume you just like check off some fields and get into exactly what you need without needing to make those introspection requests. So that should be brilliant. I think there's more, but I can't remember what else is there? Plus Relay is one of those tools, right?
Yeah. Any more questions? No. Okay, thank you very much, Viktor.